Good morning, everyone, and thank you for joining us on this beautiful leap day. Welcome to part one of a webinar series that we're kicking off today that's centered around net zero, as you can see there in the title, achieving net zero targets with renewable energy microgrids. So we are recording this session today live, and we have more Spray team members here, which I'll get to introduce you to in a minute. So throughout the conversation today and the discussion, if you have comments or questions, feel free to drop your comments in the chat. Danielle and I, a team member and I, will be responding to those comments throughout the session, and then put any questions you have in the Q&A feature as well, and we will make sure to answer those at the end, as long as we still have the remaining time. Okay, so let's get started with some brief introduction to the Spray team that's leading the conversation today, and then we can just jump into content. I'll start us off since I'm here welcoming you. My name is Kimberly Holcomb, and I head up the demand generation activities here at Spray. So that includes events, webinars. That's why something like this I'm very excited about and excited that you're joining us here today. So that's just a personal note. Super excited that you're here, that you're spending time with the Spray team, and that you'll be a part of this series going forward. And on my team, as I said, is Danielle. So I'm going to include her here on the screen as well, and we'll start off some introductions.
Yes, hello, I'm Danielle Mason. I'm the product marketing intern here at Spray, and I'm really excited for today's webinar. I've been doing all the promoting, and I'm excited to actually get into the knowledge and the conversations today. And I'll pass it on to Jackie.
Thank you, Danielle. So I'm Jackie Ling. I'm delighted to be here with you today. As a project manager at Spray, I've journeyed from my beginnings as a systems engineer through product design to quality assurance. With 7 years of hands-on experience in this ever-evolving field, I've learned a thing or two about every step of the development process. So thank you for having me here. Now I'm handing over to Nevin.
Thank you, Jackie. So my name is Nevin Thomas. I'm a analytics software developer in the analytics team of Spray. And I work on building tools using analytics data. So that's where I'm at.
Yeah, hi. Good afternoon or good morning to everybody. My name is Steve Ulrich. I am a software engineer and system architect here at Spray. Been with Spray for almost a decade now. And I'm really excited for these webinar series. I think that there's a lot of great information that we can have a good conversation with the folks and talk about where Spray can fit in and help us get to the net zero targets.
Thank you, everybody. And once again, welcome to all of you. And thank you for participating today. We started off this webinar thinking that it is going to be a one event webinar. But as we put all the content together, it turned out that, there's so much content. So it's turning into a webinar series. So hope to see you here in the future as well. I'm Sunil Charian. I'm the founder and CEO of Spray, and I've been at it for over 20 years. I've seen a lot of the changes in the industry, from renewables to storage to electric vehicles to microgrids to virtual power plants, all of those things that have been going on in the industry. One of the reasons for us to actually put this webinar together was the types of questions we've been getting from our customers or partners or prospective customers. A lot of that these days centers around the concept of net zero. How does net zero come into play? What can microgrids do? Is there a relationship between the two? And what became apparent to us was there's a lot of interest and excitement out there, but there's a lot of confusion as well. So as we tried to assemble all of this together, we thought it'd be great to have a conversation on that topic and really see how we can help guide the dialogue a little bit, maybe shed a little bit of light in the areas that we are good at. So we are looking at it from the perspective of renewable energy microgrids and how that plays a key role in contributing to our collective net zero journey. So as you already saw from my team, we have a pretty good team here. It's going to be a kind of a fun exercise. I'll kick this off by sort of setting the stage about net zero and then pass it off to my team to actually show some real activity as to how we go from sort of a concept as to, how do we take a facility with solar storage and then, do all of the data capture, data management, analytics, all of the work that's actually needed to get us on the path to net zero in a sustainable manner. So that's the objective of the series. But today, of course, given limited time, we'll be focusing on the beginning parts of it just to get us going. So that's the plan for today. With that, I'll actually dive into into a little prepared presentation up front to set the stage on net zero. Very good. Today's agenda, as you can see, it's a full agenda right there. We'll go through a little bit of an introduction to net zero, take a look at what some of the primary drivers are, look at the problem and the opportunity a little bit. And then most importantly, what we'd like to get into is, we want to act. We want to avoid analysis paralysis as much as possible. So how can we identify things that we can do and actually get moving? But when you do that, you also have to make sure that you're actually moving in generally the right direction. What's the type of foundation that any organization will need on their journey to net zero? So that'll be the primary focus, the digital foundation for net zero. Microgrid is one of the enabling tools, but really the focus is on sort of closing the loop. It's one thing to have a microgrid that does A, B, and C, but the data from there that allows you to calculate where you are on your net zero journey, what to do next, and how do you actually close that loop completely. For that, you need a robust foundation. That'll be the real focus of this webinar series. We will switch gears after that to talk a little bit about facility microgrids, and the team will dive into actually show you how microgrids are essentially built in this case, how microgrids are deployed, and then, as I mentioned, really talk about the data that microgrids typically generate. Microgrids tend to generate gigabytes of data, per day at least, and the vast majority of the data is not properly utilized other than for real-time controls. So we'll talk about how to free up the data from the controller and make it available for more general-purpose analytics. And then we'll wrap up with what's coming next and go from there. So now, moving on to the topic at hand, I mentioned the introduction to net zero and its drivers. Let's start at the very top level, if you will. As we were preparing for this, we were trying to look for background data that's actually relevant in this particular case. And two things really jumped out at me. On the left-hand side, that chart really shows, over the past, I guess in this case, 2,000 years, really what's been happening with respect to global population, gross domestic products globally, fossil fuel emissions, atmospheric CO2. And this one chart, I think, says it all. It really shows from, the industrialization period, about the 1700s onwards to now. If you look at the last 300 years, you can see how the chart is going and the correlation between emissions, population growth, GDP. So on average, I think globally, our quality of life has substantially shot through the roof, in no small measure because of the access to energy and the amount of per capita energy that we have to actually utilize. Of course, side effects are, we've been burning up a lot of fossil fuels. We've been drawing from the bank, if you will, and spending it liberally. The picture on the right-hand side shows where we are at as a consequence, right? When we look at the UN activities, the IPCC special report, all of us have heard about this 1.5 degrees C target. We have to stay under to actually prevent major climate-related, consequences all around the world. So to do that, we have to limit global warming as much as possible, as soon as possible. And the magic number these days that I think there is general consensus around is that we are in that 30-year window when we have to reverse the trend on global warming, right? So if you think about it from that perspective and you compare the two charts, on the left-hand side, it took us about 300 years to get us where we are. We have about 30 years to get back on the right path here. So it's not an easy challenge. It's quite a significant challenge when you look at it from the perspective of the rate of change of carbon growth that we have to curtail to actually stay on track. So limiting global temperature rise to 1.5 degrees C requires bringing CO2 emissions to net zero in just 3 decades. So that's the big picture problem. The real question for all of us is, what can we do today, right? And it can seem pretty overwhelming because you look at it by industry sectors, you look at it by countries, you look at it by corporations, individuals, residential homes, the actions that we need to take. You have energy, you have materials, you have transportation, you have all kinds of different contributors to this particular problem. In the last few years, I think net zero has become a very significant arrow in our quiver, I guess you could say. Net zero offers a measurable and quantifiable path to decarbonization. Some of the previous efforts like CSR and ESG and all that, there's a feeling even now that those are very soft measures. You really cannot sink your teeth into it and do something very precise very quickly. Net zero, on the other hand, is relatively straightforward, making it the perfect launching pad for other eco-friendly goals and objectives. Whether it's water, manufacturing, waste, plastics, materials, recycling. There are a lot of things that have to be done to get to true net zero, but the energy part of it we can actually tackle. And I'll, just close that thought with the Pareto principle, right? We can get 80% of the results with 20% of the effort if you actually know which 20% to focus on. That's really the trick in all of this, right? So, continuing on that thought here, this chart really shows on the left-hand side what the different sectors have to do. It's a kind of a very concise chart. By the way, all of the references are all on the slides themselves, so you can go to the source material, if you're interested in later on. A lot of information and material available on these topics. So on this chart on the left-hand side, it shows everything from buildings, transportation, industry, electricity and heat, other areas like carbon capture. A lot of things have to happen. And the most impressive thing, of course, is the slope itself, the steepness of the emissions reduction that we have to achieve over the next 30 years to actually get to net zero. So when putting it all together, I think it's pretty clear why net zero is generally a complex topic. It is actually difficult, and figuring out how to actually get going is no easy task. That being said, when we focus on the energy side of things, this chart is a very interesting one because when we talk about renewable energy is not the problem. In fact, renewable energy abundance might be the problem. We have plenty of renewable energy. If you look at the staggering numbers shown on this chart here, just solar alone, 120,000 terawatts, falling on the earth, and our global energy usage is about 15 terawatts. This data is a little old, so by now it's probably 20 terawatts or so. But again, it's a minuscule number compared to the overall energy that's available to us. Clearly, the problem, just as with most other problems, is availability where it is needed, when it is needed, and for who needs it, right? So that dispersion problem is really the challenge. The advantage is these types of renewable energy sources are available everywhere. And so from that perspective, we ought to be able to take action almost everywhere. It won't get us to 100%, but similar to the Pareto principle, it can get us to 80% relatively quickly. If we do that quickly, then we can use other mechanisms at our disposal to actually tackle the 20% as we get closer and closer to the targets that we are actually interested in. So who is acting to achieve net zero? This is a very interesting chart, I think. It shows all of the major actors in this particular space. On the left-hand side of the chart, it shows companies, cities, regions, nations, all broken up into different criteria. That the legend at the bottom shows that, those who have achieved net zero targets that are externally validated. self-declared achievers, targets that are in law, that are in policy, pledges that have been made, proposals that are actually out there, and then a lot of people that haven't really done much about it at all, right? This represents a fairly significant cross-section across the world in these categories. And the main thing that jumps out is, well, there's a lot of action in terms of pledges, policies, trying to get it into law. In terms of who has actually achieved this, you can barely make it out on that chart when it comes to the companies. The fourth row there is actually a tiny little sliver that says achieved, but it's so small, you really cannot really even see that on the graph, right? On the right-hand side, it's from a different source, but it's actually showing the cumulative net zero targets published since the launch of the corporate net zero standard in November of 23. So you're actually seeing the shape of the curve, which is actually quite interesting in the sense that the numbers are actually increasing quite rapidly. So what actions are all of these people taking? This graph is actually from the World Economic Forum. They are essentially breaking it down into different sectors and the overall journey. We are at the very front end of this journey where it says emergence. The concepts are just getting put in place, but there are many, right? The top level view is the color coding. If you look at the three colors there, the green, the blue, and the I guess the violet type color there. Clean energy uses, clean energy provision, circularity, efficiency. There are different things that you can do. And you're calling out different things there, plastics, carbon production, synthetic fuels, the manufacture of steel, concrete, things like that, shipping, carbon capture, a lot of things that we can actually do in this area. And really, these technologies have to diffuse within the industry. And then ultimately, when it becomes the new normal, then we know we're actually getting somewhere. So on this S curve of decarbonization, we are at the very front end of the journey. And there are a lot of things that we can actually do there. What we will do for this session is really to focus on energy-related activities. So we are not going to be talking about plastics recycling, even though that's extremely important in all of this. But our focus will be on energy. So we can sink our teeth into things that are happening every day, and we can do rapidly as well. So that hopefully gives you a good idea about the general nature of net zero, right? At a global scale, looking at the various aspects of that, and then when you dial into the energy part of it, what happens. So we're going to shift gears a little bit here, and then we want to dive into leveraging microgrids for net zero operations. Again, we are not presenting microgrids as the silver bullet, as one of many tools in our arsenal to actually to solve this problem, or at least move towards solving this problem. Why are microgrids important? So we'll jump to that particular topic really quickly, and I will have Steve walk us through this particular slide to give us a very quick overview of what a microgrid is, and then a couple of aspects of microgrids that are very important for us to understand. Steve?
Yes, thank you, Sunil. Yeah, so when Sunil was mentioning about microgrids, what we're talking about is what's available on the actual facility on site. And a lot of the actual operations that happen there are capturing, the real-time data, actually performing the operations to control the assets on site. And there's a certain amount of optimizations that can happen there, but on-site controls, on-site instructions are a little bit limited, with the size of how much data you can capture there at the controller. But it's a huge amount of data that we can actually capture, but it's going to be limited, based off of how much actual size you have available on site. So one of the things that Sunil had mentioned earlier was about, as we're doing the real-time controls on site, you do want to have a way that you can offload that data, push it up to other tools for analysis, get it into the cloud for various purposes. So some of the cloud services are available, and they allow the ability to to do the backup of the data, to process it in various types of ways, regularize it based off of what's actually happening, into useful time series data, take that data that's captured in the cloud, take any of the telemetry data that we have for the assets, as well as metrics and performance data that we have on site, and do additional processing. So that's for generating various types of reports that are needed for analyzing what's happening on site, as well as pushing those or making those available through additional APIs and additional parties to do advanced analytics, advanced optimization algorithms, so that we can then better utilize the on-site assets, and you can redirect what may be happening on site in a more efficient way once you've actually done more in-depth analysis. So essentially, that's where we're kind of trying to go with this, is that we're trying to make sure that the data does not get lost. That was one of the points that Sunil had mentioned earlier, was that we don't want to have this data that's useful data that's captured on site and then not be able to use that it doesn't get made available to the right sources. So let's go ahead and we're going to switch gears now, and I'm going to have Jackie, I think Nevin, you're going to bring up the user interface. We're going to talk about how do you actually go about configuring and setting up a microgrid.
Sure. So as our spray is providing a concept to operation solution for microgrids, we have some tools to help us to achieve this net zero goal. So what you are looking right now on this Nevin screen is our configuration tool. So on this tool, we kind of created three kind of systems. So the first system we call is GCRM traditional. So this is, Nevin, could you click inside of it? Thank you. So GCRM is represented as grid-connected resiliency microgrid. So you can see this is our kind of, before we adding all the renewables inside, we are kind of normally is connect to the grid. You are the utility is provide you all the energy power, and then what you have is some loads you can control, and some residential or commercial, you may have some emergency generator in your basement. So this is a very typical current kind of a power electrical here. So as our renewable energy is developed, so we are adding more kind of renewable asset, distributed asset into the system. So Nevin, would you mind switching to our second configuration? Yeah, the middle one. So if you click on it, so you will see in the middle of it, we are adding some 2 PV panels, which Nevin is highlighted. And also we are adding 3 battery in the system. So these will provide you the capability so to kind of consume some solar energy and then make sure it can be stored in the battery and then be dispatched in the time when you don't have the solar available. So this will help you eventually to achieve that net zero goal. So with this kind of configuration finished, we internally we are going to kind of deploy it against our emulation system. So we can even you don't have a solar or you don't have a battery installed on your site, so you can still see it through our emulated environment. So Nevin, would you mind open up our emulation UI? Okay, so Nema, would you mind zoom out a little bit? We can see the whole system. Thank you. So you can see this one line is very close to what we just see in our configuration tool. It's a grid connected system with generator, PV, battery, and sheddable loads in the site. So we are using this emulated system to kind of providing it with different PV profiles, providing kind of simulate different state of charge for the battery, and then maybe adding some load profile for that system to emulate it kind of a reality there. So Nevin, would you mind switching to our Wave client?
Yes.
So what you are looking right now is our wave client. So this is normally once you kind of deploy against even emulator or deploy against your field, what you are daily will be using it. So what Nevin's showing is the dashboard. So this will tell you can see on the latest view is kind of have a symbolic saying is a PCC power, was how the power flow is going from different components in the system. So Nevin, would you mind switch to System tab? So on the System tab, you can see the one line is exactly the same as what you just saw in our configuration tool. So in here, you can also observe the power flow, those kind of things from just monitor your system. And also on this page, you can also dispatch some system control in here. So I think that's wrap up my segment here. Now I'm excited to pass the torch to Steve. So he got some very fascinating insight to share about our data infrastructure. So Steve, take it away.
Yes, thank you, Jackie. So as Jackie was just mentioning, what we're looking at here is an emulated system that's currently running, and this is what an operator is going to see. And as she was mentioning, one of the things that we have running right now is we've got some of our controls are running. So scroll down, Nevin. There's when you go into our groups listing and then our system control group, you can see that we've got a number of these control objectives that we can actually run. Right now, the one that's currently spinning it in red is demand limiting, which is the control that we're currently running right now. So the demand limiting control, go ahead and select that. And then this is bringing up the faceplate where an operator can actually observe what's happening, and they can also start making some changes if they want to change the behavior of the system. But go ahead and scroll down to the bottom where we have our trend line. Keep going a little bit further down there, Nevin. So what we're showing here in this trend view, this is showing the real-time capture of the data as it's running through the system right now. Right now we've got a target demand limit of 0 kW. It's a little hard to see there, but it's in the green line. If you could zoom in a little bit to the right, Nevin. What we're looking at with the gray line on the sort of the bottom half of the trend is the loads, the total loads on the system. The emulation has just got a triangular waveform that's representing the load. So you can see it going up and down. And as the load is changing, this control is interactively balancing how the import and export is across the PCC. So with the target line at 0 kW, the goal is to not export any power back to the grid. We're trying to keep it under that 0 kW limit. So once we have our data over here running, if we want to make a change, like let's say, let's go back up to the configuration settings for the demand limiting control. Click on that little wrench icon, Nevin. We can change our settings here, change the behavior of the system. Let's just go ahead and change our demand limiting set point. And just go ahead and put in, I don't know, like a -50 kW. And then apply that change. And what's going to happen whenever Nevin applies this is that it's going to change our set point, and this will cause the control to now have to react to that new set point value. So in a second here, once the screen refreshes, you can see that the green line has now dropped from being at the 0 axis, and now it's down to the 50 kW point. The loads are still the same loads that were in the system from before. And you can see with the white line how the white line has now been affected, and the control has now dropped our PCC down. So it is going to be exporting a little bit, but it's not going to hit below that that target line. So this is just showing you how our controls are working in general, and how they are trying to achieve the objectives that our system has. Once we have all the data captured and all the controls as we just demonstrated here in place, all of this becomes now available through our APIs and is synchronized up to the cloud. So let's go ahead and let's switch over to Nevin has put together a sample program that's using our APIs to show how the APIs can actually consume the data and do a little bit of processing of the data of the values that are being sent across to the API. So go ahead, Nevin.
Yeah, thank you, Steve. So here we have an external application, and it's pulling up. So as Steve mentioned about, it's pulling data through the Waves API, and the couple of metrics it's pulling up are we have the PCC active power coming in, the frequency, the reactive power, and the ESS related metrics, and also the generator. So now you're seeing is the PCC active power, and this analytics tool also what it does is it's also process the data. So it does the calculation of the raw data by doing the average of it value by 20 seconds. So that's the blue line we are seeing it, and the raw data is the red line we are seeing. So that's on the external tool we are seeing on right now.
Yeah, so you can also see here, if you look to the right-hand side here, where the PCC reading was at before we made that demand limit change, and then the PCC dropped down once we change our demand limit set point. So as Nevin was saying, this is just a sample. This is not doing any in-depth or extensive processing of the data, but this is just giving a representation of the type of things that could be done as a starting point. And yeah, this is leading to a lot of great activities that can actually then redirect and be used for other more comprehensive processing of the data.
Well, thank you, everybody. So hopefully that gave you a little bit of an idea of how you configure microgrids, how you operate them, and sort of the advanced functionality that you can actually get in microgrids. So to summarize kind of what we saw up to now, on this chart, we just covered sort of the left-hand end of it, the baseline, sort of getting started. How do you take a facility that may or may not have solar and storage, deal with the sequence of operations? How do you configure the system? How do you deploy that and put it into operations? And sort of the basics of getting some of the analytics information that you actually need. Along with that, what we are really touching on is really what's at the bottom of the screen, sort of the ability to design, deploy, operate energy systems of various types. And then along with it, marrying up the data management infrastructure to actually do the types of analytics that are required to actually move towards net zero. So since we have limited time today, we're not going to get into all of those details. However, as I mentioned at the beginning, we are setting this up as a series of webinars, so you can actually listen into much more details as we get into different topics. One of the key ones that we'll be getting into in one of the future sessions is the one on the right-hand side of the screen, net zero calculations. If you think about these types of systems, you have self-generation, you have electricity that you're drawing from the grid that has varying degrees of carbon depending on time and location and all that. We have renewables that we are either producing ourselves directly or we are actually purchasing renewable energy credits or other mechanisms to offset our carbon footprint. You have energy storage capabilities, right? Now, the advantage and the issue with the energy storage is an energy storage unit can only put out energy that's already been put into it. So figuring out the net emissions impact of that leads to some very interesting calculations requirements. First of all, determining how do you want to charge your battery? Can it charge from any source? And if you're using a fossil fuel-based source, how do you actually account for that? Do you account for it when it actually produces the power, or do you account for it when you put it in? Bottom line is that you have to come up with some sort of net calculations on what the energy storage unit is doing. Once you have information like this, you have to mesh it up with your actual consumption information. As a simple example, when you flip on a switch or a compressor turns on, you're consuming energy. So we can talk about the carbon component of that type of energy consumption. But at the same time, if you turn on your battery, well, that's consuming power too, right? So the calculation of what is true loads versus loads that are through ancillary systems like the storage system, all of those things have to be factored in. As you saw in the systems that Jackie and Steve and Nevin were describing, we have the ability to model those systems up front, to have the exact same topology, the type of assets, the characteristics. We have the ability to inject different profiles to say this is the type of loads that we have at this particular location. This is the type of solar that we expect to actually see coming in. So we can actually configure those systems. And if that system is actually deployed in the field, you have a very powerful infrastructure off the bat. Forget about the microgrid operations for the moment. Just think about the amount of data, real-time data that you can actually collect and actually analyze. That's the type of thing that's typically very difficult to do. If you run around and try to figure out what your facility is doing from your electricity bill, well, good luck with that, right? So that's the difference between sort of very high level information and a digital information that gives you this information. Once you have collected that data and it's available in an analytics engine, you can do things like that net carbon footprint calculation. So suddenly you can figure out your baseline, and then you can figure out where you need to go from here. So we hope you'll join us for future sessions here as we look at the complexity of the infrastructure and give you some ideas on how to move forward. Just summarizing what we saw so far, this slide really on the right-hand side, it actually shows the digital infrastructure, right? At the very bottom, you have the equipment that's generating the data. The next level up is the control software that's actually managing that for different purposes. You're really optimizing for various values that you can actually capture. And from there, the analytics part that Steve and Nevin were describing, you open up that data to external consumption. So you're actually doing what we call a cloud synchronization. So you push the data from the controller to the cloud. Now, third-party applications or new applications you write or applications that Spire provides can consume that data and do different things with it. Along with it, you're also opening up the connectivity to other third-party applications, workflows. As you bring in new opportunities like market participation, the same engine can actually connect all the way up. And the data is all available in a common framework. And then you can do your net zero calculations. You can close the loop to actually say what additional actions can we take? What can we do to actually continue our journey to reduce the carbon that we are actually consuming? The left-hand side shows sort of a summary view of the process that you have to go through to actually build systems like this. Hopefully, no big surprises there. The design and deploy part of it to actually say, if I take one building or a campus or a fleet of facilities, you really have to go through the design and deployment process to activate microgrids at these different locations. Now think of them as a network of microgrids, right? Once you have that, you have the monitoring and control capability. You have the operations data. You can measure exactly what you're looking for, all the key KPIs. And then you can use that data at the minimally just for reporting, right? You can calculate the proper metrics, report to all the stakeholders, and then it opens up the analysis and optimization capabilities. And then ultimately, of course, if you like the solutions you're putting in place, you can standardize, replicate, and scale, and then add additional facilities as you go along. So you can really begin your journey with something bite-sized, with one building or one campus, and then really scale it up across multiple facilities to achieve your corporate-wide or your, if it's a region or a nation. It gives you the ability to act on a small scale and get results on a big scale. So that's really the key message here. But if you don't have the proper digital infrastructure to do this, you cannot get there. So that would be one of the key takeaways, that pay attention to that digital infrastructure up front and make sure that you're putting in something that you can experiment with at the beginning, tune in, and then essentially standardize, replicate, and scale. You don't want to end up with a very fragmented framework where you have silos of all kinds of things. Nothing talks to each other. We all know that world, right? So hopefully, as we get into net zero, we can make sure that the digitalization of the energy infrastructure is actually being done in a harmonious way, or is done in a way that actually supports long-term activities. Takeaways from today's presentation, just a few key takeaways. It's easier to get started than you might think. A lot of people think that this is very difficult to do, but the fact is you can find the right facility, the right location, the right action to actually get moving. And as I've already mentioned, the digital infrastructure, make sure that that's a common infrastructure so you don't end up with silos on that front. Avoid analysis paralysis. I think one of the biggest problems are people just overthinking the heck out of this without taking step 1 and 2, right? The journey to net zero is a long one. You cannot get to net zero before you get halfway. You cannot get halfway without getting 1/4 of the way. And you cannot even get moving if you don't even take the first step, right? So that's where we can actually act, and the risk of acting can actually be kept small. And then the biggest advantage, of course, is that as you learn, you can pick up momentum and move forward on this. You need the right platforms, and very importantly, I think you need the ability to make the results of what you're doing available to key stakeholders, whether they're internal or external. You want to be able to publish those results. Again, back to that digital environment, if the data is there, you can push it into different types of Power BI or visualization tools, reporting engines to actually make that data available much more widely. So that's a very key part as well. Several years ago, I was a co-author on a paper where one of the key takeaways in there was, we call the section data jailbreak. We basically refer to the fact that today microgrids just hold on to their data all to themselves, meaning the controller keeps all the data. It's very difficult to make the data available to external parties. What we were showing today was really step 1 in the data jailbreak, right? You're moving the data from the controller over to the cloud, to external applications, analytics engines that can do something with it, so that you can now do the proper type of analysis and close the loop through mechanisms to actually make sure that directionally you're moving towards net zero. This chart on the right just shows what I think is a very important aspect of the at the intersection of renewable energy microgrids and our net zero journey. What this shows is that getting to net zero is not just a cost. Getting to net zero is a tremendous opportunity. When you're looking at things like renewable energy microgrids, there are tremendous values that you're actually unlocking. On the left-hand side of the slide, it says, it shows demand limiting, renewables maximization, market participation, resilience, all kinds of capabilities that you can unlock. If you unlock those values with the correct digital infrastructure, your net zero journey becomes much, much more achievable. And you have this common foundation, and as you incrementally work your way up, not only are you approaching net zero, you're also unlocking these values. So it's not just a case of costs going through the roof as you approach net zero. It's really a case of unlocking values for your energy operations if done correctly. So I think this is one of the key takeaways I hope everyone gets out of this, so that we can think about net zero activities and value creation simultaneously. They go hand in hand. They're not, attacking each other. Or when you do net zero, you don't lose value elsewhere. In fact, just the opposite. You do the right things fundamentally to get the right energy infrastructure in place to unlock the values. Net zero almost comes as a side effect, so long as you have the data infrastructure to close the loop there. So that's the main takeaway. What we will do in future sessions is to dive into each of these opportunities one by one. We'll talk about how to calculate net zero metrics, and then we'll talk about how to activate these types of functions along the way, and then how do you actually continuously keep your eye on that net zero target. And hopefully we'll be able to show that the convergence to net zero happens as you activate more and more of these functions. So we are excited about being able to show off all of these capabilities, and hopefully all of you will get some new ideas about how to think about your own net zero journey. With that, well, maybe one more thought here, and then I'll pass it over to Kimberly to help wrap this up. This slide I ran across when I was looking for, just thoughts about accelerating to net zero, right? And I thought this kind of captures our the paradox that we are all facing quite well. The top bar is, by the way, this slide is about acceleration from the Khan Academy. It is talking about acceleration. Top line acceleration, the middle still acceleration. It just happens to be negative, right? And the bottom line row is also acceleration, but you're changing direction all over the place, right? So those are three versions of acceleration, if you will. We want renewables to go up. We want GHG emissions to go down. But really what happens in a lot of cases is that, when it comes to planning for net zero, we're just switching directions, going back and forth, and there's a lot of acceleration, but you're really not getting anywhere, right? So that's the type of acceleration we don't want, and I hope that we can focus on the types of that are more along the ones in the top two rows there. Just something to think about. And especially when it comes to planning for net zero, it's extremely important to have a steady and systematic way in which we actually approach that. Small steps will get us moving forward. The proper digital infrastructure will get us all the way. With that, I'll hand this back to Kimberly.
Thank you, Sunil, and thank you, team. That was amazing. We do have some kind of last minute activity in the chat and in the Q&A. There was some interest in how the data and the decision making that's available through that data, some interest in how that can connect with other OT platforms. Sunil, there's a question here about what other OT platforms you see needed to make this data actionable.
That's a good question. When we talk about OT platforms, you're generally talking about operational systems, PLCs, SCADA systems, DCS systems. Depending on the particular industry that one is, you'll have your own operational infrastructure there. The trick is to actually figure out how to get the best out of that and really connect it up to new systems that will be required. Just as an example, if you have a power plant that's actually running on, has let's say a DCS system or whatever, chances are that was custom programmed for that particular facility. They do their job very, very well, and you have to, you'd want to take advantage of that. That being said, that type of infrastructure is not very flexible. It's very, very time-consuming and expensive and difficult to actually make changes to that. So you want to find ways to actually interface those systems with an adjacent system that'll give you a lot more flexibility. In our case, while Wave has a lot of control functions, very often we have to interface with systems that are already there. So defining that interface appropriately, connecting the two sides up, will give you the best of both worlds. That will be the key to actually doing that. What is probably a little bit more insidious is, you usually use, IT and OT in the same sentence, right? So you actually saw in our demo today, connecting up the two sides. What Nevin showed was an external analytics application that can sit anywhere. You can use any application there, much more conventional in the sense that it'll sit on the IT side of the house. But once you open up that data pipe, you can now go to that site and actually open up all of the values of so many mature technologies. Today, I guess you cannot have a meeting without talking about AI and ChatGPT and whatnot. But there's a lot of interest in actually bringing in capabilities like that to actually say, how can we use AI ML techniques to actually figure out what the heck to do with these gigabytes of data that's being pushed up into the cloud? With this approach, you're now going all the way from OT to the bridge technologies to the IT side and connecting up to the new infrastructures to do all of this. So that's exactly what I mean by the digital infrastructure. Making them connect up seamlessly is the name of the game, but we have plenty of tools to do that today.
Amazing. There are a couple other questions here. We have about 10 minutes. I know you briefly touched on this at the beginning, but someone did ask how common you are seeing net zero as a main objective for our customers.
Great question. If you'd asked me that 2 years ago, I would have said, it's just a lot of talk in the hype cycle kind of thing. So everybody talks about it, nobody does anything about it kind of thing. That being said, I think we are now in the last couple of years, substantially finding that conversation is up front and really center of the conversation. In fact, we have several engagement with prospective customers who are coming at it straight from that perspective, saying, how do we get to net zero? Or how can we get to 80% carbon reduction? So variations on the same theme, but that's the driving factor for a lot of the conversations about renewable energy microgrids. So I think that momentum is only going to continue to increase. That being said, just like the pushback you're seeing a little bit on things like ESG, where there's the fear that the data is not auditable, it's not quantifiable. So there's kind of this back and forth in the industry, right? Everybody wants it, and then all the negatives keep coming out. So I think net zero is probably going to go through a similar type of a cycle where there's be a lot of hype around it. And then, the reality will be that you're not actually getting there. Like the charts that I showed you, the people that are actually achieving that are very, very few, or it barely registers on the map. So that's the type of journey I think we are on. But I think that the majority of people looking at any type of improvements in energy are going to be looking at net zero and ways in which you can actually move in that direction. Because it's such a diverse area with everything from plastics or materials recycling onwards included in that, it'll be a big bucket. So we'll have to be pretty precise about which areas we are tackling, and then we can actually make progress. But I think that conversation is here to stay for the foreseeable future.
So this one's kind of related to what you were just talking about, so I'll bring it up. And someone's also liked the question, so hopefully there's some interest here. The question is, how will this data that you're speaking about now drive decision making in the future? I think I would add to that too, of like, what type of decisions do you think this will drive in the future?
Well, now I have to put in a plug for the next session, right? So I mentioned a couple of times how we'll go about doing all the underlying calculations to figure out where you stand on that net zero journey. So today's conversation was more about establishing the infrastructure to create the baseline that's actually absolutely essential. So once you establish a baseline, you can actually pick up the different actions that would be necessary to get there. So when you talk about what this data will actually drive, think about it from maybe 3 different perspectives. Step 1 is establishing that baseline and communicating that with your stakeholders. That communication part is very, very key. Whether it's internal to one organization, whether it's a community, whether it's at a national level, that communication is very important. And it'll only be meaningful if you actually have an auditable foundation, meaning that what you're dealing with is real, right? It's not just happy thought on a PowerPoint. So that's one part of it. The second part is really, as I mentioned, quantifying the specific actions you take. Normally what happens is that when you brainstorm what you can actually do, you'll generate dozens or hundreds of ideas of what you can actually do. That's where the Pareto principle comes in, and you have to pick the first few to actually get started with. When you do that, you'll end up with let's just say 1 or 2 projects that you can actually act on. At that point, you can laser in, execute on that, and with the proper foundation, that'll feed right into the communications that you've been having. You can compare against the baseline, show the progress, in a very meaningful way. And then the last step is really coming back to that overall net zero journey, that S curve that we were looking at. We're all at the very front end of that curve, right? That inflection point where you're picking up momentum, that's going to be very key. And that's the type of data analytics that you can actually do to say, where are you on that journey, either as an individual organization or a community or as a nation? So that third part is really the macro picture, and and how we move towards those targets. That's really what we can actually do there. So those are maybe three ways to think about how this data can be a very important piece of actually meeting those very aggressive targets. 30 years, that's all we've got, right? So essentially you cannot waste the first three at all, and I think this way of looking at the data will hopefully help us do exactly that.
Okay, I think this should probably be the last one. Thanks for taking all these to know. Kind of similar to what you're talking about with the Pareto principle of making the most impact or the most concentrated area has the most impact. This question says, what collaborations between industries or what partnerships are most important to making this work or to achieving net zero?
Well, there's a big one.
Yeah, that's a tall order.
Yeah. I have two perspectives on that. I think stakeholder engagement, is absolutely essential, right? So if you want to do anything about our own, let's say, electricity infrastructure, you cannot get away from the regulations and policies in that particular area. You have to work with your electric utility to make sure your interconnection agreements are all met and they're progressing in the right direction. The things like tax incentives and all come into play. So the stakeholders that are actually essential for doing these things at scale, that's very, very important. So that's one half of the coin, right? The other half is that we can act by ourselves. These constraints that we have, whether it's a grid interconnection or the existing incentive structure that we have, there's ability to do things today. So I think the answer to your question is really the balancing act between the two. We cannot just wait for all the stakeholders to align before we do anything at all, in which case we will do absolutely nothing. We have to act by ourselves, and I think nothing speaks louder than success, right? So if we can have showcase projects that any of us do, then the stakeholders will get something to actually align around. One of the projects that we did here in Fort Collins was called the RDSI projects a few years ago. It was amazing to see how the stakeholders actually come around something like that when there's something specific to align around. Where you don't get alignment is really when everything is theoretical, right? When everything is theoretical, everything is possible and nothing actually gets done. So I think that's the difference between the two. So I would say we should find that balance between actually acting and then allowing stakeholders to crystallize around those things. And it's a two-way street, of course, but that's probably what we need to do to actually make material progress in these areas.
All right. Thank you so much, Sunil, and thank you, team, as well, for showcasing so much and sharing your insights. Thank you to everyone who joined on this part one of hopefully a continuing series that continues to add value in your area of work and your organization as well, and maybe even just spark some thoughts around this area and starts to drive some of those goals and objectives. And we will see you soon.